And so first, let's do a quick review of what is it, R2R ladder. First of all, why we came here? That was because for big N's, the difference between the smallest r and biggest r becomes very big, and finding proper components with good accuracy that gives you that is hard. But over here, you have r and 2r, and it will be nice and easy to find good resistors that will give you exactly what you're looking for. Now, I have two rails, A rail and B rail. A rail feeds to my feedback resistor. B rail does not feed to my feedback resistor. That's the difference. So A feeds feedback resistor, and B does not feed feedback resistor. If I pay attention to this, the rest is a snap. Why? Because I have a bunch of switches. You can imagine them in the middle, and those switches, if I have a logic 1 corresponding to that switch, it will connect to the rail that feeds the feedback resistor. So for example, this S1, as you can see now, the S1 here, how can I point to it? The S1 is, I think the eraser was working nicely, yeah. So the S1 is now connected to this rail, which means whatever current goes through here will contribute to the feedback resistor. And this switch, S2, is connected to the B rail, which means whatever current comes through this resistor, it's gonna go to waste. It's not gonna contribute to my feedback resistor. So my feedback resistor, whatever current goes through it, should be a representation of my digital value. Therefore, any of my bits that are 1, I put them on this way, and any of my bits that are 0, I put them on that way. Let's do a quick example, like simple questions that I can ask you, and you answer. One of the first one, for a D2A with N equal to 10, how many 2R resistors we need? And I mean just for the ladder. So we ignore the feedback resistor, because the feedback resistor is special. You can actually rate it the way you like so that it gives you exactly the voltage you are interested in. So let's forget about that. But how many 2R resistors do you have? 2R resistors for an N-bit D2A. Whatever N is, it's N plus 1, because you have, every switch has 1 2R resistor, and there's 1 extra at the end. Why do we need that extra at the end? It's just because, remember how these two become parallel and they make a R, and so you need that to weight it, the last one. There's nothing special about it. So the answer to that is N plus 1. Another question. Let's say for a D2A with N equal to 4, and if D is equal to 1 0 1 1, how many switches are connected to B rail and how many to A rail? How many? So which one is what? The 1 0 1 1, A rail is which one? Is the one that contributes or does not contribute? It contributes. I have 3 1s and 1 0. So how many of them are connected to A rail? 3. And how many of them are connected to B rail? 1. The last question I ask you is that for the same number that I am doing this, the second one, the second bit from MSP, so not MSP, but the second one, which switch is that? So if I want, remember you just said that we have n plus 1, 2 R's. So that's 1, 2 R. Forget about here. I actually don't want to show the top because it makes it 1, 2 R, another, and another. Which one is it that is not connected to any switch? The first one or the last one? The all the way to the end is the one that is not connected to any switch. The one all the way to the left, is it MSP or LSP? MSP. It's something like this. You would say this is MSP, this is MSP minus 1. It goes all the way to LSP, and it goes even below that, like nothing. Like you go from LSP to nothingness, like we don't even care about you. So you have your switches. That means this bit is connected to here. Any question? Yes.
If you were to have a VREF minus that's not 0 volts, would that last resistor to
Very good question. I'm not going to answer. I put it to the whole class. If you had a VREF minus that was not 0, where would that VREF minus show up? Your actually homework was like that first, then I felt bad and I changed it. But it's a good question to think about it. The question is this. In this example, VREF minus is 0. If VREF minus was not 0, let's say it was 2 volts, how would we change this so that it can convert digital voltages that such that your output is actually where would you put it? Yes.
you just added 2 extra sources, but then 2 volts comes down,
Where? Say it again.
So if we have VREF, we figure out some way to put some resistors and automatically connect it in to get the voltage difference between them.
Basically, when you have, so the answer to your question, something like your friends are saying, that you can, in using circuits, multiply any voltage by whatever voltage you like by going through different resistors. You can add any voltage you like by making your difference with something that is higher. For example, the thing that is matter to you is this, that the current that goes through that resistor is a linear addition of whatever that is 1. So that's the weight of it. But over here, the voltage V out is minus Ri out. What you would like to change on this, you want to make it such that it is like minus VREF minus Ri out, something like that. And for that, all you need is, for example, to change the voltage of A rail and B rail. And it shouldn't be VREF minus, it should be negative VREF minus. Because because the current is going that way, if you put VREF minus here, the VREF minus itself, then over here, you're going to get VREF minus the output, which is not what you want. You want it